Okay, class. This is a 5.2. We stopped 5.2 last time and we did question. The last example, the last problem we did was question number 8. Okay, let's try to do one of them where we have the initial value. Let's try to do question number 16. We have an initial value. Okay, I will show you, and the next we can go to the chapter 5.3. That's the next one. Okay, let's try to do one example on here. Okay, here they ask you when you are dealing with this, and they ask you, what's the question again? I believe it's just to found. This is a question, you can go read it. But the main one is just to find the solution of the initial value. So here you can tell the initial value here is just x is equal to 0 because of this one here. Because of let me change the color so you can see, because of this one here. That's the initial value. Okay, let's go back. Okay. Okay, the Taylor series will look, the solution will look xy is equal to the series going from n is equal to 0 to infinity, for example, and you have a n and x to the n. This is a form of the solution will looks. Now you take the first derivative, just like I told you last time. If you take the first derivative, the series will start to 1 to infinity, and you have n, a n, x to the n minus 1. And you take the second derivative, you have the series will start to n is equal to 2, n factor by n minus 1, and you have a n, x, n minus 2. Okay. Now you can go ahead and replace it back. You have 2 times 2 plus x squared, series going from n is equal to infinity, and you have n parentheses n minus 1, a n and x n minus 2. Minus x, series is the first derivative going from n is equal to 1 to infinity, and you have n, a n, x n minus 1. And plus 4, and you have the series going from n is equal to 0 to infinity of a n, x to the n is equal to 0. Okay, we have this now. So now we can go distribute inside. So you have series n going from 2 to infinity, and you have 2n, and you have 2n, n minus 1, a n, x n minus 2. So if you feel you understand, you can go ahead, just move it fast, that's okay. And you have plus series n is equal to 2 to infinity, and you have n parentheses n minus 1, a n and x. Minus 1 minus 2 plus 2, it's just 0, it's just x to the n. And then you can put this one inside. You have the series from n going from 1 to infinity, and you have n, a n, x to the n minus 1 plus 1, and then plus series going from n is equal to 1 to infinity. And you can move the 4 inside. X to the n is equal to 0. Okay, you have this one. Now, let's try to, okay, here. Let me just do it directly here from here so you can see. Here, here, minus 1 minus 2 plus 2 is just 0. So I can go ahead just change it just to x to the n. Got it? And same as here. Here I have minus 1 plus 1. I can go here, just say x to the n. So I can write down as x to the n. That's it. Okay, now you can just go ahead, combine them. So if you, let's try to use a demi variable. Let's call it n or k, j. Let's call it j is equal to here. Let's change it here first. Let me do it in color so I can separate them. Here I can choose j is equal to n minus 2. That means n is equal to j plus 2. Okay, this is the first one you can choose from here. So the second one, if you check here, you have already x to the n. You're good. This one is fine because you have x to the n. This one also same. Here also same. So you don't have to do anything except this one. It's only this part you have to change, and I already changed it. So if you keep going with this, you will have series going from j is equal to 0, because if you replace n by here, you have j plus 2 is equal to 2, then j is just 0 to infinity, and you have 2 times j plus 2, and then you have j plus 2 minus 1 is just j plus 1, parentheses, and you have 8j plus 2, and then you have x to the j. Okay, you have this. The next one, make sure to write all of them in term of j, not in term of n. All of them in term of j. So you have j star to 2 to infinity, and you have n. Okay, let me point out something before I move on. Okay, look at here. If you look at here, n star to 2, but I already have n here. So I can go ahead and change it to n is equal to 0. It's the same thing because of this one, n. Same as here, I can start from 0. Okay, here I can start from 0 also. I can also start from 1. It won't change. If you start from 0 also, it won't change because of the 2 expression. But here I can also start from 0. It won't change the expression because of those expressions. Just to make sure you understand, okay? So I can go ahead, start from j is equal to 0 to infinity of n, of j, sorry about it, of j, and j minus 1, and you have j. Nothing won't change. Don't change anything. You just have to use a demi variable and change it from j is equal to 0. Same as here. You can start to j is equal to 0 from infinity, and you have j, aj, x to the j. Okay? The last one now, you can't not start from 0. Why? Because you don't have no n here. There is no n. You have to keep the n is equal to 1. Again, you can't not start to n is equal to 1. No, leave it like that. So I can write down as j is equal to 1 to infinity of 4 aj x to the j. Okay, is equal to 0. Okay. Now I can go ahead, store all of them, everything from n is equal to 1. Okay, I can go ahead and store all of them n equal to 1 because of here I cannot change it. I cannot do anything about it. Okay, because of here, if n is equal to 0, it will change. You cannot do that. So the only way is just to leave it as like this and change everything to n is equal to 0. Okay. Okay. If j is equal to 1, if j is equal to 0 here, I will have 2 times 2 because of here, and then here you have just 1 times 2 plus j is equal to 0, nothing won't change. J is equal to here, let me point out here. If j is equal to 0, nothing won't change. J is equal to 0, also same thing. But here, if j is equal to 0, I will have this, okay? And then plus j is equal to, let me go ahead, change it back to n. Let me use the demi variable, change it back, j is equal to n. So then it's n is stored to 1 to infinity, open the bracket. Now they have the same thing. It's just 2 times j plus 1 parenthesis j plus 2. Let me change it to n. It's n plus 1 parenthesis n plus 2. And then you have 8n plus 2 and plus n minus 1, and then 8n, and then plus an, and then plus 4an, and then everything to the n is equal to 0. That's it, okay? And now you can try to distribute this, move it outside, and then what do we get? But since, look at here. Since I got this one, an, I can distribute them easily. So what I get is 482 is equal to, 482 plus the inside one. The inside, I will have n is equal to 1 to infinity, and I will have 2n plus 1 parenthesis n plus 2, and then an plus 2 plus, if I factorize by n, I will have n parenthesis, let me factorize by an, I will have n square minus n plus 4 parenthesis an is x to the n is equal to 0. Okay, now I have this one. So what I should do is to move it outside, and you can tell here a0 will be what, and all I know, the recurrence relation is when you take the inside one and set it is equal to 0. That's the recurrence relation. So the recurrence relation will become an plus 2 is equal to, move this one outside, and you know this one will cancel out. So if you move it outside, you have a negative divided by n squared plus 4 and divide by 2 parentheses n plus 1 parentheses n plus 2. And you have an. Okay? This is the recurrence relation. And you have 4an is equal to 0. That means a2 is equal to 0. So you have the recurrence relation here. Now we can express it. Let me just check if I didn't make no mistake. I have the second derivative here. Okay. I think everything is fine. I have negative 4 here, x to the n. It's easy to make a mistake. It's very easy. You have to be very careful. And 4, okay. Here I have this. So now if n is equal to 0, it's already here. Okay, if n is equal to 0, be careful here. Look at here how we are dealing with a contradiction now. If n is equal to 0, what we get here is 8, 4. But this one cannot be careful, because if n is equal to 0, we have a2 is equal to negative 4 divided by 4, a0, which is negative a0, which is the true one. We cannot get this one is equal to 0. You have to set only this one is equal to 0. Why? Because you can have negative 4 a2 here. You can have negative 4a here. Okay? That's why it cannot be true. So we have this one. If n is equal to 1, you have a3 is equal to negative 1 is 5 divided by 1 is 2 times 3. So let's see what we get. We get negative 5 divided by 4. 4 times is 12. And we get is 8 is equal to 1. We get a1. Okay? That's exactly what we get. We get a3 is equal to 5 over 2 if I didn't make no mistake. If 8 is equal to 1, you have 5, here you have 2, 3, 6, or here is 6. 1 is 2 is 4, 1 is 3, 6, 12. Okay, leave it like that. So here you have if n is equal to 3, so it's and so on, you have a1. N is equal to 2, you have 8. 4 is equal to negative, and is 2, you have 4, 8. And divide by 2, you have 3, 6. 2 is 4. And you end up having 8 times 4 times 2 times 3 is just negative 1, because this one we cancel out is 8. Negative 3 over 8 is equal to 2. You have here a2. You have a2 here. Okay. So now we can replace it back here, and we will have I think is 6. 6 is 2 times. We just make sure it's true. 2 times 3 is 6. Okay. And this one we cancel out. We have this. Okay. Now we can just go ahead and replace it back by a2. We have a4 is equal to, you have to express a2, a4 in terms of a0. Everything have to be expressed with term of a0, a0, or a1. So we have a2, and remember it's negative 1 over 3 parentheses. a2 is negative a0, and which become a0 divided by 3. And so on, so on, so on. You can keep going, you end up, okay, let me just go ahead to 1. If I didn't make no mistake, computing is exactly the process. Just understand the process, that's all. The rest is just computation. Let's go ahead, try if n is equal to 3. So you have a5 is equal to negative parentheses, and you have 3 is 6 here. If you put the 3 here, you have 6. 3 is 9. 9 plus 4, and you have 2 times 3 and 4, and you have 3 and 5. Okay. You have negative 13 divided by 20. 20 times 2 is 40, and you have 8. N is equal to 3. You have 3 here, and times 3 is equal to negative 1 over 3, 40. 40 is just 8 times 5. 8 times 5 times negative 5 over 12, and you have A1. So A5 will become, the negative sign will cancel out, the 5 will cancel out, and then you end up having 13 divided by 8 times 12. So in terms of A1, 13, 12 times 8, 96. You have 13 divided by 96, A1. Okay. You keep going, so on. Okay, you will end up having those. So now to find the general solution now, A1, remember, is the general solution was an, and going from 0 to infinity of x to the n. This you can expand it to A0 plus A1x plus A2x squared plus A3x to the third, and so on. Okay, and you can also keep going to 8 to 8 4 x to the 4 plus 8 5 x to the 5th, and so on. So now I have yx is equal to a0 plus a1x plus a2. If you go here, a2 is just here. That's a2, okay? That's a2. And if you remember, a3 is right here. a4 is right here. And just replace it, that's it. And a3 is negative a0. Parentheses, negative a0, okay? I just want you to understand the process, that's all, okay? And you have x squared plus a3. If you remember, a3 is just a negative 5 over 12, and you have a1, parentheses, a3 is right here, x to the third, plus a4. a4 is a0 divided by 3, parentheses, x to the 5th, x to the 4, okay, x to the 4. Now, 8 to the 5th is 13 divided by 96, a1, x to the 5th, and so on. So now the general solution we can express as a0, parentheses, any a0, replace it. You have 1 minus x squared, and then you have plus 1 over 3 x to the 4. Any x naught, substitute, and you have plus so on. And then plus factorized by a1, you will have, factorized by a1, you will have here x. And then the next one you have negative 5 divided by 12, a1, or factorized by a. So you have x to the third. And then here you have plus 13 divided by 96, a1, okay? X to the 5th, okay? And so on, and so on. So now you have this one. This is your general solution. So the question they ask you is to find they may ask you to find something different, or the question they ask you is just to find the initials, the given, yes, the given value are, yeah, those y0 is equal to 1 and y prime of 0 is equal to 3. So now, if those are given, we just found a1 and a2, that's all. Now, y0, here, yeah, let me show you here. See here? So we have, those will help you just to find a1 and a2, that's it. So a1, let me go ahead here. So first of all, I advise you to take derivative first. We take the derivative first. Derivative of this one will become a y prime is equal to 8 parentheses negative 2x plus 4 divided by 3x and so on. And here you have a1 parentheses 1 minus 3 cancel out with the 12, it will become 4 is 5 over 4, and then x square, and then plus 13 times 5 divided by 96 x to the 4 and so on. Okay, now y0 is equal to negative 1, that's the given. So y0 here, you can see everything here is 0. Everything here is 0. Y0 here, everything here is 0 except 1. So you have y1 is equal to negative 1. Got it? Now y prime of 0, replace x by 0 on y prime. You will have only y1, and y1 is equal to 3. So then for we have our final solution will looks negative parentheses, and we have 1 minus x squared plus 1 over third x to the 4 and so on. And we have plus 3 parentheses, and we have x minus 5 over 12 x to the third and plus 13 divided by 96 x to the 5th and so on. That's it. That's all they ask you. That's the solution. Okay, that's the solution. Okay, let me know if you have any question, any issue. That's it. I think now we